Mine's on page 19.
Oh, is it on page 19? Oh, it is 19. Sorry. Yeah, page 19. Okay, so we're going back to this interest thing. So we talked about simple interest versus compound interest. So they're used for different things, usually for like smaller loans or personal loans. That's when you're going to use simple interest. And the reason that's the case is because it's actually quite simple. So I actually lied to you guys up here on purpose. You were doing something the hard way. You were calculating out compound interest over time. The actual way to do simple interest is you just plug it in that formula and boom, that's it. You don't need to do year 1, year 2, year 3. We have a different formula for that. You were calculating compound interest while you did that, because if you remember, again, let's go to that $10 million. You've won the lottery. You want to live off the interest thing. If you remember, you would end up getting $10,175,000. That's how much you would have got after a year of interest. I forget what percent we use, but for the sake of the example, sure. If you were to then calculate, so you can't actually calculate this again, taking this, okay, so now I got to figure out what percent of this was. Instead of adding 175,000, maybe it added 177,000 or something. That is not simple interest. So do you understand where the extra $2,000 came from? You gained interest on the previous interest that you've gained. So on that.
So the 175,000 you're paying against the 2,000.
Something like that. Yeah. So like if you gain money, or if you gain money off of other interest that you've earned. So if you're earning interest off of other interest, that is not simple. It's not simple interest. Simple interest is going to be, I earned 175,000 in year 1. I earned $175,000 in year 2. I earned $175,000 in year 3. It's simple, as the name implies. So what you guys were doing here with this question, when I said break it up in year 1, 2, 3, and 4, that was technically wrong. I wanted to kind of get into that just because you were actually calculating compound interest, because however much you made here off this $1,000, you were technically like getting a couple extra cents every year because you technically had more money. So, so if we're going into this here, so for the compound interest, so the technical definition of this is it's the interest paid on the principal. Remember, that's the amount you put in, amount you invested, plus interest. So it's the interest. So it's when you gain compound interest, you made money on that $10 million you put in, and on that extra $175,000, and then the next year, and on that extra $177,000, $177,000.
Let's say 7% interest, right?
Yeah.
And I put 10 million in there.
You would get $700,000 a year at that. Yeah. Now on year 1, if you were doing compound interest, that's how much you'd make on year 1. Then you'd get interest on that $700,000 as well. So it'd be like you get 700 and I don't know 5, something like that, interest the next year, and then like 709 interest the year after that, and so on. It's going to keep building and growing.
So I put $100 every year. $7.
On simple interest, yes. On complex, no. Or on compound, no. So compound interest is it's the interest paid on the principal plus the interest. So that's what makes this different than the simple interest. Now the compounding period. So most of the times the stuff we were doing was every year, and that's it. But when you get to these more complicated interests, that's not the case. Sometimes your valuation of stuff goes up after a month, after a year, every week, every 2 times a year. It all depends. It all changes. And this is why, like, usually when people are looking at buying a house or buying a car, they'll literally go to a calculator and like put all the information in. Like, you have this option, this option, this option. They'll figure out which one's going to be cheaper over time. So a compounding period is the time between calculations of interest. This is also called the interest period. So compounding period is the amount of time between calculations of interest. So if you have something that calculates yearly, it happens once. If you have something that, yeah.
So let's say your car,
Mhm.
example, right?
Yeah.
Calculated interest, that would be like interest period. You gotta pay this much each month. If you don't get it, that interest comes off.
Yeah, so like, oh yeah, they calculate, they figure out, let's say you take a 5-year car loan on like a $3,000 car. With interest, that's eventually going to go up to like, I don't know, like $3,500. I'm picking easier numbers here. So you're paying that but your payment reflects that, okay, over 5 years, I have to pay $3,500. So that's how that works. But you are paying that interest, yes. And so compound interest accumulates at different paces. If it's once a year, it happens once a year. But you're going to get these terms here: semi-annually, quarterly, monthly, daily. There's also stuff like bi-monthly, bi-weekly. So semi-annually happens twice a year. So you divide the interest rate by 2. So now let's imagine the interest rate is like 4%, 0.04. If it happens once a year, cool, 0.04. That's it. If it happens semi-annually, twice a year, it's over 2. If it happens quarterly, you divide this thing by 4 because it's happened in 4 separate times. They spread out that 4% at different points in the year. And the reason that's important is because, again, the more this happens, you're gaining a little, like maybe it's only a couple cents each time it does it. You're gaining a little bit of extra money over time. And that can have a huge effect. Like that's what your pension is. Your pension is just a giant compound interest saving account. That's what it is. You do, yes. And you want to do it. It's like because this compound stuff really takes off. If you put in good money between 20 and 30 years old, you're going to have like twice as much money as a guy who started at 30. 10 years can double the amount by the time you retire. So quarterly, you divide it by 4. For monthly, you divide it by 12. And then for daily, you divide it by 365. And there's other terms here as well. But just to give you like an idea here. And I'll show you what I mean by what I mean divide by in a second. So everyone got that in? Cool. So you have a formula here. Now it looks a little complicated. Once we actually put numbers in here, it'll make a lot more sense of what's actually happening here. But this is the formula. A equals P1 plus R over N. Am I resuming again? Yeah, I am. All to the power of N to the times T. Sounds really complex. It looks really complex. This is all of our friends here again, A, P, R, N, and T that we've seen before. So I'm just going to really quickly kind of pen that down here, just so I have that. So A equals P1 plus R over N and T. You don't need to do this, but it's helpful to like have the definition. I'll update your formula sheet with this one. So you'll have this going into the exam, just so you know. Oops. Okay, so this question here is asking us if you have $1,000 deposited in an account and it gives you 4% interest per annum, that means per year, and it's compounded, so it's compound interest every year, compounded annually. What happens? How much are you going to have if you left that with 2 years? And they want us to figure out the difference between compound interest and simple interest. So A and B. So I'm going to put compound on the left side here. So compound interest. Oop. So if you remember, that whole thing was that's the amount is equal to the principal 1 plus, I'll write that in a second. That's the N divided by, or R divided by N there. And then all to the power of N and T. So what was this? This was R over N. R over N, and then that's supposed to be times N and T. So let's substitute this stuff in. I put my formula in. Is that big enough?
That'd be like, that'd be 1,800.
Close. You're on the right track. So A is equal to, my principal here was 1,000 times in a bracket. So 1 plus, so N. N is sorry, that's an R. That's supposed to be an R. So R, if you remember, was my annual interest rate expressed as a decimal. So 4% expressed as a decimal is 0.04. And then the N here, that is the amount of times, that's the number of compounding periods in a year. So if this is compounded annually, once a year. Annually is once a year. So it's divided by 1. Cool. And then it's all to the power of NT. So remember, N, that's the exact, whatever you put down here is exactly what you're going to have up there. I'm going to put a little times here. T is the length of the term, right? It's how long the investment is. This whole investment is how long? Sorry? 2 years. Yeah. So that's what you'd put in your calculator here. Bear with me while mine loads. There we go. Cool. So I'm literally going to put it in exactly how you see it. 1,000 bracket. That's these things here. It's 1 plus, put a fraction, 0.04. Oops. 0.04. All to the power of 1. Close that bracket. Sorry, all divided by 1. And then you take, if you want to put something up here, you need to press this symbol here, right? This Y with a little X on it. You click that. And then you can put 1 times 2 up here. You could also just put 2 if you can do the math there. But so it's that little button there to get to a whole exponent thing. So does everyone have that in their calculator? So you have this in your calculator, and if you end up pressing equals, you should get an answer of $1,081.60. So this whole thing, at the end of it, after 2 years, your investment turns into $1,081.60. That's with compound interest. Now with simple interest, if you remember, if you go all the way up a couple different pages, our formula here, there's 2 of them. A is equal to P plus I, principal plus interest. And the second, and the second formula, because we have to figure out what the interest is. To figure out the interest, that one was just I equals PRT. So I'm going to figure out my interest. So my interest is equal to P is the principal. So that's $1,000 times R was the rate of interest as a decimal, so 0.04 times T is the amount of the length of the year, how long is being invested for in years, right? So 1,000 times 0.04 times 2, you get $1,080. Sorry, you get $80 over here. And then when you add that 80 up on the left side, 1,000 plus 80, you get $1,080. Just gonna kind of circle those. Cool. So again, someone tell me why. How come compound interest, this person earned more money? Why did someone earn more money doing compound interest? Sorry? You gain more interest on what? Well, let's say the interest rate's the same, but you gain more money through the interest. Times 2. No, well, it's times 2 over here as well, which again, like I see where you guys are like looking at it. So the reason you're earning more on compound versus simple is because remember, this is a 2-year investment, right? So year 1, year 2. On the first year, you're going to get $1,040 over here. 4% of this $1,000. So if you were to change this 2 to a 1, you get $1,040 here. But now for year 2, this formula changes. It's now $1,040. So you have a different principal. You now have a bigger investment that they're calculating that interest on. So if you were to take 4% of this money right here of 1,040, you'd get $41.60. So it's adding in this additional interest, this previous interest. It's calculating that and adding more into it. So you gain interest on previous interest. Now, whereas if we're over here in year one, you'd still get the 1,040, but then they're still going to give you that extra $40 instead. So it just goes up by 40 because they calculated, hey, yeah, this is like that. The reason they did this is because at least as far as I'm aware, back in the old days, they didn't have computers and calculators for this. It was a lot easier just to do simple interest because it's close. It's very close, but over a long enough time or with a big enough sum of money, that $1.60 could equate to literally millions of dollars for different people. So that's the difference between comp.
Okay, say that again.
Which part, Bill?
When you put money in and then it builds, right?
Yeah. Oh. So carrying forward here, we're gonna do example here because like this one's a little bit easier in that it's compounded annually, once a year. Boom, that's it. Where it gets a little bit more complicated and where the changes can really add up is when we compound it semi-annually, monthly, weekly. So for question 2 here, so this is it's not the same question. I want to change this to, I want you to change this to 4%. And I want this to still be over a period of 2 years. So this is the exact same figures as what we have up here. Sorry, I meant to change that, I didn't. So cross out 2.8, put 4%, cross out 4 years, put 2 years. And same thing, instead of having to flip back, I'm just going to rewrite my formula really quickly. So P 1 plus R over N, and then N T. Cool. You don't have to do that, but it's a good habit to get into, and it helps you memorize it. Okay, so now that we have that, let's quickly run into this. So if something's happened semi-annually, how many times is that compounded in a year? Is it calculating that interest? That's why I ask. So if we semi-annually happens twice a year. So the interest gets calculated twice a year. So I'm just gonna put a little. Sorry?
I was gonna say 2, but I did not.
Oh, yeah, guessing's always fine. Yeah, 2 times. So I'm going to quickly kind of pen this in. So I have my formula up here. Instead of writing the blank formula, then filling it in, I've already written it up here. I'm just going to fill it in. So A is equal to, it's $1,000 is my principal. 1, the R is my interest rate. So 4% as a decimal is 0.04. Then the whole thing's going to be divided by N. Now, N was the number of times that it's compounded. Yeah, so N was number of compounded periods in a year. It's being compounded semi-annually twice a year. I put a 2 there. You're right. And then up here, I put N times T. So 2, and then T is the amount of years, right? So 2 times how many years? 2 years. There's 2 years here. Yeah. So I'm just going to put 4 up here. You can put 2 times 2 if you want. That's okay. You can do that. But cool. So now all I need to do is just punch it in my calculator, right? That's it. It's literally just filling in the blanks. In fact, you can even do it like this way if you really wanted. You could even backspace, 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 or you could write the whole thing again. Instead of a 1, this is a 2 here. Cool. So everything else here should be the exact same though. That's what looks right. So if I plug this in, I now get $1,082.43. Again, you see how this is now worth more. It compounded twice now in a year. So now you're gaining a couple cents, a little bit more each time. So this whole thing's gonna be 1,082 and how many cents was it? And 43 cents. So really, really quickly, just write down, do exactly what you did up here. Take this formula, fill it in, write down what you think the formula would be here. A equals 1,000, and then fill in those brackets and other stuff. So I'll give you 30 seconds to do that.
I don't know what the password is.
Oh, there? If you press this button right here, y to the power of x. So you should end up getting something though that looks like, so this is 0.04 divided by 4. And then up here, what's up here? 4 times 2, right? So you're gonna have 8 up there. So what do you get as an answer there? Here we go. So here's our answer. 1,082 and then 86 cents. Let's take a look. What'd you press? Oh, you got it correct. So press the BS button. Yeah, then use your right arrow. Yeah. So now you close the bracket. Cool. So we have our answer here. Now, before you do question C, which is monthly, I have a question for you. What's your prediction for how much money is it going to be? Higher or lower than this? You think lower? You feel like it's gonna make more? So we'll find out. So this is what you put in your calculator. You put $1,000 times 1 plus 0.04, all divided by 12. And then to the power of 12 times over, to it compounds 12 times over 2 years. So there's 24 up here. So if you were to put this all in your calculator, you would end up getting backspace. 24, $1,083.14. So it did go up. So the reason it's going up, if you remember, is because you're now calculating that interest. You're calculating interest on more interest. Like the more this happens, like even though it's an extra cent, maybe it's only an extra cent, you're still getting a little bit more each time. What did I say? And 80, and 14. Yeah, when stuff compounds more frequently, it means that the interest increases faster or more. So this is really good from a savings perspective. This is really bad if you owe someone money. Again, we're only doing 2 years. If this is over a period of 10 years, the difference between the simple and the compound would be like probably a couple $100. So this is where stuff like Money Marts, is it like, I think it's Money Mart. Like if you ever go to like one of the cities, you'll see one of those places where you can like take a really quick loan out. It's at like a 50% interest rate. So that means like if you, let's say you take out $1,000 from them and you don't pay it off after that first month, you now owe them $1,500. Month 2 happens, you now owe them $2,200.50. Month 3 happens, you now owe them like $3,300. So I know people who have taken out a very short loan from like Money Mart and like a couple $100, and by the end of the year, they've owed them literally thousands of dollars. So never use it. Like take out a credit card before you have to do that. Okay. So what I'm gonna get you guys to do is not for the whole class, just for a bit here. I don't know how long. I'm gonna give you, why don't we say a half hour or so? Give you about 30 minutes to work on these practice questions. We're gonna introduce you to a new rule after as well. It's called the rule of 72. But for now, you guys get like 20, 30 minutes to work on some of these questions. We'll go over maybe one of them in a bit as well. So kind of with the next part here is it's actually nothing really new. So like this is not going to take long, what we're going to do. But if you go down to page 24, there's something called the rule of 72. And this has to do with compound interest or simple interest too. I guess it also works with that. Which is, so the rule of 72, where's my text? Is generally speaking, so let's say, for example, I put $1,000 into a bank account. How long is it going to take to double it? We don't know. Like you don't know, but that's what the rule of 72 helps you figure out. How long is it going to take for the money to double just from the interest that gets added on to it? So how you estimate this? So this is a way to estimate the time it takes. Oh, that's supposed to not be capitalized. So a way to estimate the time it takes for an investment to double. That's it. How long does it take for $1,000 to turn to $2,000? You know, for $1 million to turn to $2 million. And so how you do this is you just take, so you divide 72 by the interest rate as a percentage. So normally whenever we have interest rates, we do it by decimals. This is the one exception to that. Oh, double. Investment to double. So when it says estimate, this doesn't mean exactly. It's just a really close. And I'll show you an example of that. Give it a second. Everyone has that down? Cool. So you divide 72 by the interest rate as a percentage. So if I have this question here, it wants to know how long it's going to take for an investment of $5,000 at 3.75% compounded annually to double in value. That's what it's asking us, right? So how I can figure this out is use the rules of 72. So I take 72. I'm going to divide that by the interest rate as a percentage. And if it's as a percentage, that means it's the 3.75. This is the one time you get to keep it like this. Everywhere else in the class we've ever used a percentage, it's always been 0 point something, or like we turn it into a decimal. Cool. So if I do this, I'm going to get 19.2 years. I get 19.2. So it's saying after 19.2 years, that $5,000 will turn into $10,000. And that's part of the reason why investing really early into a retirement like fund, even if it's like $50 a month, is huge to do that in your 20s versus when you're like 30. I wish I would have done that in my 20s. If I would have done that, I could have retired at like 50. Okay, so you don't need this next part doesn't really matter. So you don't need to write this next part down, but I just want to show you. So if I were to take that compound interest formula and I were to plug this stuff in, I'd get, what would this be? 5,000 times 1 plus 0.75 0.375. Imagine there's a 3 here. 375 all over. It's compounded annually, so 1. And this whole thing's to the power of 19.2 because it's 1 times 19.2. So if I were to do that, so 19.2 up here to the power, or it's divided by 1, and then this is 375. Oh, and then it's $5,000. Not 1,000. Cool. So if I put this in here, after 19.2 years, I get $10,137, right? So it's a good estimate as to how long it took that 5,000 to turn to 10,000. It's not exact. There's an extra $137 there, but that's not the point of it. It's just a brief estimate. That's it. So that's what the rule of 72 is. Just show, it's a way to figure out how long it's going to take something to double. So where I got this, so 72 is kind of in here. It's this 19.2 up here, which we got by taking 72, dividing it by the interest rate. So I typed, it was to the power of 1 because it's compounded once per year times 19.2 years. So there's a 19.2 up there. Does that make sense? And like that's it. Literally, that's it for the, like that's all we're doing. Yeah. So our plan, so you guys get some more time to work on that stuff for now. Our plan for next week, I just might as well just tell you now, we're going to be doing, we have credit card stuff, which is really, really important. Come on. We're going to have credit card stuff, and then, where are you? Yeah, credit card and loans that are going to happen Monday, maybe a bit of Tuesday. We'll see. And then on Tuesday, Wednesday, it's kind of like review stuff. I'll be giving you some stuff to work on. On Thursday, we will have the exam for that on the afternoon. So Aiden, you do not need to come in on Friday because they're doing the English departmental on the Friday. Yeah, yeah. You're welcome to come in the morning if you want. That's more time to review. So the morning will be review. The afternoon will be the exam. Yeah. Yeah. So you guys get a bit more time here to work on this stuff.